of linear equations. There are basically two ways to do this. The first one is by having graph, and the second one by calculation. Okay, if we have, let's say, system of linear equations, what does it mean by it? All right, I give you an example here. This is example which is extracted from the current textbook. Example 1, graphical solutions of a system. So we have the first equation here, 4x plus 3y equivalent to 11. And then the second one here is 2x minus 5y equivalent to minus 1. Call this equation 2. So in a system, we have two equations. Alright. So it's a collection of equations basically, and in this case it's a linear equations because we can see clearly the highest power of x here is 1, or the highest power of independent variable here is 1. Now the idea here is that when we talk about solutions of system, what does it mean? We need to find what's the value of x, what's the value of y if we're given this kind of system. So like I said, we have two methods. The first one is graph. Let's look at the first method here. So we have two equations here, equation 1 and equation 2. What we need to do here is that to draw the graph for equation 1 and 2. How do we draw it? You did learn how to draw graph. So for instance, if we have equation 1 here, 4x plus 3y equivalent to 11, and we want to put y on the vertical axis and x on the horizontal axis, what should you do? We rearrange this equation first so that we only have y on the left hand side and the rest on the right hand side, including x. Okay, so in this case, if we bring 4x to the right hand side, so we only left with 3y. So that means 11 minus 4x, isn't it? Then we simplify it further. Y equivalent to 11 over 3 minus 4 over 3x. So once you have this equation comes from equation 1 here, let's call this one equation 1a, then what you need to find here is to find the m, or the slope, and you also need to find the intercept here, vertical intercept and also horizontal intercept. So this is the thing that we have learned earlier, yeah, so I don't want to show in detail anymore for this exercise. So once you have the vertical intercept, horizontal intercept, the m and the equation, and then you can join the vertical intercept and horizontal intercept here to get the line. So for the first one here, 4x plus 3y is given by this line, the downsloping one. Do the same for the second equation, 2x minus 5y equivalent to minus 1. Then you're going to get the upsloping line here, right, given by this equation. So if you draw it according to the scale, alright, so if you have 2 here, you have the same distance of 2 here. So that's what I mean by according to scale. And then when we draw the graph, you can see clearly that the two lines here intersect each other at this point. Okay, and this point, it so happens that the coordinate is 2, 1. So that gives you the answer for x and y. 2 here refers to x, and then 1 here refers to y. That's one way of having graphical solution. Here is very simple. Yeah? If you want to see whether you have solution or not for x and y, or for any kind of variables for systems of linear equation, is for you to check whether these two equation here, equation 1 and equation 2, can intersect each other or not. By logic, if one equation is downsloping, another equation is upsloping, then they have chance to intersect. What happens if we have this? Okay, so if the graphs, or if the if the lines here is a parallel lines, so what happens? They can never meet each other, isn't it? They can never meet each other. For instance, this and this. Let's call this one 1. Let's call this one 2. And you know that from the previous study is that when we have parallel lines, it means the two lines here have the same slope. Okay, same slope. Okay, OM. Slopes is the same. Okay, so here, furthermore, when the slope is the same, what makes them different? What makes them, not identical to each other is just because that they have different intercept. Okay, and you can see clearly, let's say equation 1 here given by 4x plus 3y equivalent to 4. If you see equation 2 here, 8x plus 6y equivalent to 18. If you divide 2 by, equation 2 by 2, what do you get here? So 8x divided by 2, you're going to get 4x. 6y, you're going to get 3y. 18, you divide by 2, here, you're going to get, let's say, 9. Okay? So you can see clearly here, if you change it, so you have 3y equivalent to 9 minus 4x. Okay, you have y equivalent to 9 over 3 minus 4 over 3x. And here, if you rearrange it, 3y equivalent to 4, okay, minus 4x, y equivalent to 4 over 3 minus 4 over 3x. You can see clearly here, the slope here is equivalent to this slope, isn't it? Okay, alright, so in this case, when we can't find the solution for what is x, what is y, when they are parallel, this system is what we call inconsistent system, because you can't find the results here due to the same slope and leads to the parallel lines. Okay, so that's one example in which you can't find solution. Now let's look at another example here. Okay, let's say we have these two, lines in the system. This is number 1, this is number 2. So number 1 here and number 2. You look at number 2 here. If you can see 4x, 8x, 3y, 6y, 4 and 8, for each of them, the second equation is just a double of the first one, isn't it? So that means if you divide equation 2 by 2, what do you get? 8x divided by 2, okay, you're going to get 4x. 6y divided by 2, you're going to get 3y. 8 divided by 2, you're going to get 4. Isn't it just identical to the first one, except that it is double? So that's why you have, double values here. So because they are identical, so if you draw 1 and 2, they, overlap each other. So this is what we call dependent system. When it is dependent system, so is actually 1 and 2 is actually just one equation instead of 2 equations. So the system only have one equation but 2 unknowns. So unless if you can find the exact value of y, then you cannot find, you can't never find x. Alright. So here we have 2 unknowns in one equation, so you can't find the solution. Okay. Alright. So that's are the possibilities in which you can't find solution for certain linear system. Okay, now so we have done the graphical part here, and furthermore, not only is difficult to draw, is because if you have a lot of equation in the system, it becomes messy. So that's why we can have alternative here. We have calculation. So solution by substitution, solution by eliminations, in terms of calculation. Okay, so let's look at solution by substitution first. Okay, but before we go to solution by substitution, what we can conclude from this and also this is that we may have equivalent system, for something like this. All right. One expression is replaced by an equivalent expression. 2 equations are interchanged, basically, therefore. And number 3, a multiple of one equation is added to another equation. An equation is multiplied by a non-zero constant. When an equation is multiplied by a non-zero equation, that's why it leads to, this parallel system, okay, or identical system like this. Okay, now let's look at the example of a solution by substitution. Okay, so let's say we are given a system like this: 2x plus 3y equivalent to 4. Call this equation 1. X minus 2y equivalent to 3. Call this equation 2. Alright, so we need to find what is x and what is y, isn't it? Alright, so how do we solve it basically here? Okay, so let me rewrite again the equation here. Initially 2x plus 3y equivalent to 4, I call it equation 1. And then another one here, x minus 2y equivalent to 3, so we call this equation 2. So here, what we can do, if we want to substitute, we can either substitute x back into 1 or the other, y back into original equation to find y. Alright, so let's say I want to come up with x. I use equation 2 here, so I rearrange it 3 plus 2y. Do you get what I'm doing? Okay, 3 plus 2y. Okay, let's call this equation equation 3. Okay, so what we can do is equation 3, we have found x equivalent 3 plus 2y. We substitute it back into equation 1 so that we can find y, or we can solve for y. So here substitute 3 into y. You have to write down this sentence, yeah, before you embark into the next step. Otherwise, it is just number without explanation, so your reader can't understand. So please bear in mind that if you don't write these kind of steps, then I may deduct your mark also when it comes to quizzes and whatnot. Don't expect reader to understand. Make reader understand what you are doing. Okay, so here, so we have 2x plus 3y equivalent to 4 from equation 1. Substitute, then we can have 3 plus 2y plus 3y equivalent to 4. Alright, then we simplify it further. 6 plus 4y plus 3y equivalent to 4. 6, okay, plus 7y equivalent to 4. 7y equal to 4. Bring 6 to the right hand side. So you have 2, 7y. Alright, which is minus 2 here, yeah. And then y here is minus 2 over 7. So that is our y here. Once you get y, substitute y equivalent to minus 2 over 7 into either one of these to get x. Alright, because we need to solve system. Solving system means finding x, finding y. Okay, so here so let's say we substitute it into 2. So here x minus 2y equivalent to 3, x minus 2 minus 2 over 7 equivalent to 3, x plus 4 over 7 equivalent to 3. X is actually 3 minus 4 over 7. Now 3 here, because the denominator is 7, so least common denominator is 7, so you have 21 minus 4, 7, 7. So you're left with 17 over 7. So you have your x 17 over 7. Simplify further. Don't just leave it like that. In the textbook, as you can see, it leaves 17 over 7, but I want you to simplify it further. It becomes 2, 3 over 7, isn't it? So you have 2 points here. X equivalent to 2, 3 over 7, and y equivalent to minus 2 over 7. Okay, so that's how. Why it is called substitute? Because you can see clearly here, we rearrange equation 2 so that we get x. We substitute it back into equation 1. Substitute, so solution by substitution. Now, we have example number 2 here. Why don't you try at home, yeah? Because I don't want to show you. You can imitate the textbook, see the step, and do it one by one. But don't forget, when you do it, when you try to substitute and whatnot, write down the sentence, substitute into 1 and 1. Label the equation first. Okay? Alright. Now, let's move to the next one. We have substitution by elimination. And actually, in mathematics, we can have many ways to solve it. So I'm just showing you these two methods here. So we can eliminate one of the variable in the system, yeah, by elimination method. So we want to eliminate one variable because we have two variables. So because those two variables we don't know the value, so we eliminate one variable first so that we can find the other variable. Once we get the answer for the other variable, we substitute it back into equation to get the first variable that we have eliminated earlier. Okay, so let's say here we want to solve this system, the same system. No, it's not the same system. Yeah, sorry. So we have equation 1, 2x minus 5y equivalent to 4, and equation 2 here is actually x plus 2y equivalent to 3. Okay, so here what we can do with equation 1 here, you can see clearly it is written here. Multiply equation 2 by minus 2. When you multiply equation 2 by minus 2, okay, this is still equation 1, equation 2. So here we have 2 times x plus 2y equivalent to 3. Then it becomes 4x plus 4y equivalent to 3, which is, 3 times 2 times 2 equivalent to 6, which is this. So call this new equation as equation 3. So it becomes minus, yeah, because multiply it by minus 2. Once again, minus 2 multiplied by x plus 2y in bracket equivalent, and then on the left hand side also multiply by minus 2. Okay, so you get here minus 2x. Sorry, this is a mistake. Let me start all over again so that you won't be confused, although it looks so simple. Okay, so here multiply equation 2 by minus 2. So you have equation 2 here, x plus 2y equivalent to 3, multiply by minus 2, it becomes, alright, 2 minus 2, x plus 2y equal to 3 times minus 2. So it becomes minus 2x plus minus 4y equals to minus 6, which is this one actually, yeah, this one. So call this one as equation 3. Okay, now you can see clearly, let me erase the mess first. You can see clearly that we have minus 2x in equation 3. That equation 3 is a new equation from equation 2 because we modified equation 2 earlier, yeah? And you look at equation 1, we have 2x. So what's the purpose of multiplying equation 2 by minus 2? When we look at the name here, solution by elimination, basically we want to eliminate 2x in equation 1. How to eliminate it? We have to plus it with minus 2x, then it becomes 0, isn't it? So here the next step is 1, equation 1 plus equation 3 here gives you this answer. Okay, because 2x plus minus 2x becomes 0x, minus 5y plus minus 4y becomes minus 9y, 4 plus minus 6 becomes minus 2. Now here then we can solve further. It becomes 9y equivalent to minus 2. Then you cross multiply, you get y equivalent to minus 9y equivalent to minus 2. Then you're going to get y equivalent to positive 2 over 9. Once you get y equivalent to 2 over 9, then you can substitute y back into either equation 1 or equation 2, and then you solve it. Once you solve it, you get x, and x is 23 over 9. You simplify it further, yeah, because this textbook, the writer didn't simplify. So when you simplify, it becomes 2 and what? The remainder, 5 over 9, isn't it? Okay. How do you know that your answer for x here is correct and for y here is correct? Substitute y equivalent to 2 over 9 into either one of these. Let's say you pick number 1. So substitute y here equivalent to 2 over 9. If you choose 1, to substitute y into 1, You use 1 also to substitute x equivalent to 23 over 9 back into here. I know the final answer has been simplified, but for the matter of checking calculation, you use this one, yeah, so that it becomes easier for you to find the answer. When you check, it is correct, then your x and y are correct in terms of calculation. Okay, now let's move to the next example here, example 3. If you're given example in the form of sentences like this here, how do you gonna solve the system of linear equation? So this is a typical example of investment bank. You have seen a similar pattern of question in the previous quiz. Okay, so now you have here a person has a total amount of money equivalent to 200,000. Okay, and then part of it, at 9%, part is at 8%. I mean, there is the first investment, 9% yield, second investment, 8% yield. So if we invest in these two, the total investment income earned is 17,200 in terms of dividend. Okay, in terms of dividend. So let's say the first one investment here we call it X, the second one here we call it Y. So if you have X plus Y, you get total investment which is 200, isn't it? But in terms of total dividend earned, you have 0.09x plus 0.08y, isn't it? Then you need to solve it. Okay, so here let's call this one equation 1, this one equation 2 here. So if you solve it by elimination process, not by substitution, then what should we do? We should first eliminate, choose one variable that we need to eliminate. Here we have two variables, x and y. So choose either one of them and then try to figure out what to do with equation 1 or equation 2 in order to eliminate that chosen variable. Okay, when you eliminate that chosen variable after certain arithmetic operation becomes vanished. Okay, so here what we can do, let's say I multiply equation 1 by minus 8. When I multiply equation 1 here by minus 8, x becomes minus 8x, isn't it? Y becomes minus 8y, isn't it? Okay, and then this one becomes what? Minus 1, 6, 0, 0, 0, 0, 0, 0. It becomes 16 million minus. Call this one equation 3. Now next, okay, let's look at equation 2. Let's say we multiply 2 by 100. Okay, by positive 100. Then it becomes what? 0.09x multiplied by 100 becomes 9x plus 0.08y multiplied by 100 becomes 8y. 17,200 becomes 1720000. All this equation 4. Can you see? I first multiply by equation 1 by minus 8 and then multiply equation 2 by 100. What's the purpose? Because I want to figure out, I want to, in this case, I already have in my mind that I want to omit or to delete y. In order to delete y, the value of y here must be equivalent to the value of y here, isn't it? So my way of thinking is, why don't I multiply here by 8 and multiply here by 8? Okay. Then I can do something on it. Sorry, this one multiplied by 8 is second equation multiplied by 100, so that I can have minus 8y and plus 8y. So now, next step, I bring it here, yeah? Next step is to add equation 3 plus equation 4. So when you add equation 3 plus equation 4, minus 8x plus 9x becomes what? Becomes x only. And then plus what? Plus 0y, because why it becomes 0y? Because minus 8y plus 8y becomes 0, isn't it? And what about minus 16 million plus 1720000 here? Then it becomes, okay, it becomes what? 120,000. So let me rewrite the answer here. So it becomes, okay, x plus 0y equivalent to 100,020. So I call this equation 5. Now, once I have this equation 5, x is equivalent to 1. So I have found x. So y is what? Y is actually, I know that the total investment is 200,000. Then I minus x. Then I get 80,000. That's the answer. Okay? Alright. Now, let's look at the applications of functions in business and economics. So the first thing is to look at total cost, total revenue, and also profit. So you have learned in principle of microeconomics that profit estimates on its product is the difference between what and what? Between revenue and also cost. So let's say X units are produced and sold. So formally, in generic form, we can have profit function given by Px as a function of Rx minus Cx, where Px is profit from sale of X units, Rx is total revenue from sales of the same X units, and Cx is a total cost of production and also sale of X units. So here in general, revenue is found by what? So if we have profit function here, revenue consists of price times quantity, in this case X, and then you have minus cost. And for cost, it can be categorized into two different categories here, fixed cost and also variable cost. So what is fixed cost? Fixed cost, as you know, for instance, depreciation, rent, utilities, and so on. Or when you purchase a factory, for instance, you buy it once, and the cost remain constant regardless the number of units you produce. On the other hand, we also have another second category of cost, which is called variable cost, VC. This cost directly related to the number of units produced. So usually, if you increase the number of production of quantity produced or output produced, then you have to pay more for each of the increasing quantity than your variable cost. This is basically a variable cost. So the total cost is given by variable cost plus fixed cost. Now let's look at an example here, because we want to show you how linear functions can be used in business and economics here. So we want to come up with a linear function using this example. Example 1, cost, revenue, and profit. So let's say suppose a firm manufactures MP3 players and sells them for 50 each. Okay, the cost incurred in the production and sales of the MP3 players are $200,000 plus $10 for each player produced and sold. Write down the profit function for the production and sales of the player. So we know that in general, profit function is given by revenue minus cost. Because we use quantity variable x as quantity, so let x be quantity of MP3 players. Okay. Alright, so this is your generic function, and we know that profit function is therefore equivalent to revenue, and we know that revenue is equivalent to price times quantity, and then we have minus cost. So So price times quantity here. This is the revenue, sorry, profit function. So how to come up with profit function? Let's go back to the question here. We need to extract some information from the question. Okay. So the question says sells them for 50. So this 50 is actually sold at the price of 50. So that's the first information that we get. And then we have the cost. The first cost in the production here is $200,000. And then another cost is 10 for every X, isn't it? So here, before you proceed with writing the profit function, you need to recognize 200 refers to what kind of cost, 10 refers to what kind of cost. Okay, so 200 here, regardless the quantity sold, so this one is fixed cost. What about 10 for every X here? So if we have X number, then the total cost here is 10 times X, isn't it? So this 10 times X is actually variable cost. Okay, so now, so we have cost function, we have revenue function. So revenue function is P times X, in this case P times 50, isn't it? 50 times X. Okay, and the cost function here, we know that initially it is total fixed cost plus total variable cost, and we have recognized that fixed cost is 200,000 and variable cost is 10 for every X. So here 200,000 total fixed cost. So total variable cost is what? If it is 10 for every X, so if it is total X, so $10 times X, isn't it? So that's the cost function. Okay, so we have cost function, this one, and then we have revenue function. So what we can do with this revenue function and cost function, substitute it back into profit function. So you have 50x minus cost function, and cost function here is 200,000 plus 10x. So basically we can simplify further the function. So if I were to simplify it, then I have to open the bracket for cost function. So 50x stay the same, minus, open the bracket, it becomes minus 200,000, and then open the bracket, we have minus mix plus, then it becomes minus 10x. Okay, so this one and this one, they have the same common factor, then we can subtract them, so it becomes 40x minus 200,000. So this is our profit function. We have constructed a profit function, a linear function, and there are two variables here. One is X, one is profit. Okay, two variables. So this is an example of linear equation. Okay, now in relation to this linear equation, let me rewrite again the information that I got from the question. So we know the price is $50 or bucks, and then we know that the revenue here is 50x because price times quantity, and then not only that, we also know total fixed cost equivalent to 200,000. We also know the variable cost equivalent to 10x, and we also know that we found the profit function equivalent to 40x minus 200,000. Okay, now from here we want to recognize the slope. Okay, so here if we look at the generic function of linear, y equivalent to mx plus t, or y equivalent to ax plus b, something like that. So here, if we look at total fixed cost, total variable cost, so and profit function. Okay, so let's look at profit function first. So y in this case depends on x, isn't it? So in profit function, y is actually px, okay, and mx is actually this, isn't it? And then C is actually minus 200,000, isn't it? So if X is here, what is M? M is 40, or we know that the slope of Px, isn't it? Okay, and in the study of economics here, the slope, if you have answer equivalent to 40, that means if you increase X by 1, then your profit will increase by 40. Additional profit will increase by 40. So in economic study, what does it mean by this 40 actually? If I increase output, produced and sold by 1, if I manage to sell one more output, one more product, then my profit will increase by, there will be additional profit by 40. In economics, this is what we call marginal profit. Yeah, marginal means additional. Okay, so 40 here is actually marginal profit. There is a symbol in writing marginal profit. Later you're gonna study derivative. Usually we do something like this. Okay, all right, now let's go back to these two. Okay, now we know that these two combined together we get cost function, which is 200,000 plus 10x, isn't it? So if we compare it, let's say I use different color, with y equal to mx plus c, y equal to mx plus c. So obviously y in this case is total cost, mx is this one minus 10x, and therefore c is this one. So as you can see here, x is x, therefore m is minus 10. Sorry, not minus here, plus. It's plus here. Okay, so let me rewrite it clearly so that you are not confused. Okay. Plus, so should be plus. Alright, so the slope of the cost function is 10. Like I said here, slope, rate of change, is basically marginal of the total function. It's a marginal of the total function. In the previous example, in this case, this is marginal profit of the total profit function. So this one is what? If this is a cost function, this one is marginal cost of the total cost function. Okay? What about total fixed cost here? Total fixed cost is equivalent to 200,000. As you can see, it doesn't depend on the number of quantity produced and sold. So no matter what happens, total fixed cost stays the same, isn't it? So when it stays the same, when you calculate the marginal, you wouldn't find there is no change in marginal. So we don't talk about marginal fixed cost. Okay, we don't talk about it. Alright, now, and we see here variable cost is 10x. So you can see here, if you have y equivalent to mx plus c, and then you have variable cost equivalent to 10x. So obviously y in this case is variable cost, mx is 10x, but c here is 0, isn't it? So your m here is 10. In economic study, because this one is marginal, therefore it is marginal variable cost. Okay. If we have another example here, let's see this. Okay, example 2, marginal cost. Suppose that the cost in dollar for a product is C equivalent to 21.75x plus 4,890. What is the marginal cost for this product and what does it mean? Again, we have y equal to mx plus c. So y is c here x is this bit, so C is this one. So since x is x, so m is 21.75. So this because this one is total cost function, this is marginal cost. Marginal cost here, if we increase and sell one additional unit of product, in this case x increases by 1 unit, then our additional cost, or also known as marginal cost, will increase by $21.75. Okay, so that's how we read it. So this is one example of the linear equation system. Now we move to the second example, break-even analysis. Alright. For break-even analysis here, if we have profit function equivalent to revenue minus cost, there will be some situation in which some new businesses, when they produce, they just manage to cover the cost. That means, okay, their profit is actually zero, isn't it? When their profit is actually zero, we know that profit is revenue minus cost, isn't it? That implies revenue is equal to cost, isn't it? So this is the condition for break even. Okay, so if we have curve, two curves, revenue and also cost, when they intersect each other, then that's where we have break even. Okay, but then if total cost is more than total revenue, you are making losses, isn't it? But if you have revenue more than total cost, then you're making profit. But you have them the same, then you just have break even situation or condition. Okay, now let's look at one example here. I extracted the example here from the exercise in the textbook. This example: a manufacturer of shower surrounds has a revenue function of Rx equivalent to 81.5x, where x is the number of shower surround, and then the cost function here is Cx equivalent to 63x plus 1,850. Find the number of units that must be sold to have break even. So this is one example of the application of linear equation. So how do you answer it? Let me rewrite again the equation here. Okay, so we have Rx equivalent to 81.5x, and then we have cost function, which is 63x plus 1850. 63x plus 1850. Okay, break even condition is what? Is when revenue equals to cost. So here we need to substitute it. 81.5x equals to 63x plus 1850. Now, if you just write like this without writing break-even condition, then for me it's wrong, because any kind of function you can easily write like this without specifying what it is, but then people won't understand what you're doing. It is a specific condition in economic study. So you must write break-even condition is what? Break-even condition is R equal to C. So once you have R equals to C, you plug in the number here, you rearrange it to solve the problem, isn't it? Then you have 1850. And then when you solve it, that's where you get X, which is 18.5x equal to 1850, and X 1850, you cross multiply, you get 18.5, then you get 100x. So for this firm to get break even, at least to cover the cost, they must produce X or quantity of product equivalent to 100. Okay, so that's one example. You can find many examples from the chapter, especially at the end of the chapter exercise. Okay, now we move to the third application of linear equation here, system of linear equation, where we have supply, demand, and market equilibrium. So we know that in the market we can have supply, we can have demand. So market equilibrium condition that you have learned earlier before you enter this class is that price of demand must equal to price of supply, or you can begin with quantity demanded equals to quantity supply. So that means you have two equations. One is for demand, one is for supply. So when you lump them together in order to find price and Q, then when you draw it, because like I said to you earlier, we have two methods. Yeah, the first one is using graph, the second one using calculation. So let's say we have graph here, and then let's assume that the graph here is drawn according to scale, so that when they intersect at the right value. So here, this is the supply curve, this is the demand curve. They intersect here, equilibrium price, equilibrium quantity. And then you know that this one is 10, this one is 30, this one is obviously 20, and then this one is 130, and then 100 something here. So probably 150. Okay, so here you can see clearly in this system, market equilibrium system, you have two lines. The first one is supply, the second one is demand. They can intersect each other if they go different direction. If they go the same direction, for instance like this, like I mentioned earlier, then they are parallel, then they cannot meet each other, isn't it? So you can't find the answer, and then you would say that the result here is unreliable. Okay, now continue with the system of demand and supply. So if the supply and demand curves for a commodity are graphed on the same coordinate system with the same units, market equilibrium occurs at the point where the curves intersect, like I told you earlier. So in order for you to use graph to get the right answer, you have to make sure that the drawing is according to scale, and then you draft the graph for demand and supply, then you can find the answer. Okay, so market equilibrium occurs at the point where the curves intersect. In this case, the intersection here is this. Okay, this is the intersection, and therefore they have price of 20 and also quantity here of 150. Okay, now, so like I said earlier, the answer for this figure is actually 150 and 20. So you have 150x, and then you have 20y. Alright, so that means at the equilibrium here, what does it mean here? The price is 20, and then consumer are willing to get product equivalent to 150. Okay, and at the same time, because it's equilibrium, the producer is also willing to produce at 150 with the price of 20 in the market. Okay, so the result here is meaningful because when you interpret it, it makes sense. But when you get results equivalent to minus, then you have to check your calculus. Yeah, so that's what it says just now. This means that when the price is 20, consumers are willing to purchase the same number of units, 150, that producers are willing to supply. So producers also will supply 150 at the price of 20. Okay, so in general, if you want to get equilibrium market, you must get positive price and also positive quantity amount. Okay, but then okay, so when you solve it, so So this is solving a system equation or solving simultaneously. Alright, but if we are given equation like this, then so how do you solve it? So here this one is P demand, P supply, equilibrium condition is what? Ps equals to 4Q plus 1, and PD equals to PSPD equals to minus 3Q plus 36. Okay, so here equilibrium condition says what? When PS equilibrium condition says PS or PD, up to you which one comes first, equals to PS price of demand equals to price of supply. So in this case demand is what? Minus 3Q plus 36, supply is what? 4Q plus 1. Then you rearrange it, okay, until you get Q equivalent to 5, and therefore price is equivalent to what? Equivalent to 21. Show all the work, how do you gonna get this answer? If you don't show, just answer bluntly, then I don't give you any marks. Okay, now we move to the last bit of linear equations application with the last example of linear functions in applications of business and economics. Now we're talking about supply and demand with taxation. Okay, so like I said earlier, we are talking about a system of linear equations. So how supply and demand, let alone taxation, can be a system of linear equation. Alright, so we learn from principle of micro that we have supply, we have demand, we combine both of them, then we have market, isn't it? So mathematically speaking, we're going to have supply function or supply equation, we're going to have demand function or demand equation, and then we solve it to find price and quantity demanded at equilibrium point. Okay, so this can be solved using a system of equations, and in particular for this specific case we are talking about linear, so it's about system of linear equation. Now let's look at the theoretical bit of it first. Alright, so usually if you look at this graph here, we have downsloping demand function, upsloping supply function. So the first one here is supply before tax, so price as a function of quantity. Okay, so this is the initial equilibrium, let's call it PE, QE. Now let's say a supplier is taxed K amount per unit sold. When it is taxed, then this is very clear that it is on supply side. And remember, when you study principle of micro, when we talk about taxation, it's usually the determinants of supply, not the determinants of demand. So bear in mind about that. So that's why when we look at supply and demand, only supply being affected, as you can see, because when tax increases, let's go back to the study of principle of micro. Tax is one of the determinants of supply. Okay, when tax is increasing, is imposed, then obviously it will increase the cost of production. So when cost of production increases, it will reduce the amount of supply at every price level. So that's why you can see supply shift to the left. Reduce the supply for every level of price by the amount of K. Okay, by the amount of K. So that's why you can see it's a shift to the left. Okay, supply shift upward or shift to the left by the amount of K. Let's say pick one quantity, Q1. So you see the distance here is K amount. Pick another quantity here, Q2, you can also see here the distance is also K amount. Let's say we pick QE here, initially here, and then the new one here. So the distance here between this and also this is also Q. Do you get me? Alright, now let me clean the mess first. Alright, now, so as a consequence, we need to find the new equilibrium. So adjustment takes place as usual, then there will be, you know, shift to the left of supply curve of the tax from P as a function of Q to P as a function of Q plus K amount of tax. So adjustment takes place from point A to point B, then we reach to the new equilibrium, let's say QE prime to PE prime. Okay? Alright, so that will affect the price. You can see quantity in the market equilibrium quantity reduces from QE to QE prime, price increases from PE to PE prime, which makes sense because once you have tax, of course everybody could assume that the price will increase. Now, let's look at the more practical example in maths. So let's look here. The supply and demand functions for dryers are given as follows. So supply here is P equivalent to 2Q plus 170, and demand here is P equivalent to minus 5Q plus 450. So the equilibrium point here, so if the wholesaler is taxed 14 per unit, so what is the new equilibrium point? Okay, so we have supply function and demand function. The results here is before tax. Okay, so if we try to visualize it in the form of graph, so we have quantity here, we have price here. So if you draw the curve based on what I taught you last time, how to draw linear curve, then you should know that demand curve look like this. This is demand curve. This is before tax. Okay, and then we have supply curve. Okay, equal to 2Q plus 170. Okay, so if you see here, 170 here, 450 here, and then what's the idea here? So if you have this, try to figure out what's the quantity here, and then so here I'm not going to figure out what's the quantity here, what is it here, and whatnot, because I already taught you how to draw a linear curve and to find the vertical intercept, horizontal intercept, join the 2 points and whatnot. Okay, now, so the initial equilibrium here, quantity is for T, and then the price here is 250, so the price here is in terms of dollar. Now, when tax is increased, let's call it K, and it's equivalent to 14. It will immediately affect the supply curve, and because a cost of production increases, and then they will reduce the supply may shift to the left. The supply may shift to the left by K amount here. So because of that, we need to find the new supply function. The new supply function, call it P prime, is equivalent to 2Q plus 170 plus 14. Okay, so P prime equivalent to 2Q plus 180, 4, isn't it? Alright, now let me erase this so that I have more space to show you. Alright, now to answer the question, we need to find the new equilibrium. How to find the new equilibrium? New equilibrium condition is basically given by, the new price on supply side, P prime, equivalent to the demand here, the same demand. There is no change in the demand here. Alright, so if I were to put it in the form of graph here, that means the supply curve will shift upward to the left to P prime here, okay, in which P prime here equivalent to 2Q plus 184. Okay, so we should find the new equilibrium here for price and also quantity. So it moves from point A to point B. So if you visualize, you can see clearly that the price will increase, the quantity in equilibrium quantity in the market would decrease. So here P prime. So 2Q plus 184 equals to P. Take the demand here, minus 5Q plus 450. What do we get here? And then you rearrange it. Okay, so we have here 2Q. Bring minus 5Q to the left, then it becomes positive 5Q. And then we stay with 450. Bring 184 to the right, it becomes minus 184. So if you solve it, then you're going to get 7Q equals to 266. You proceed with, sorry, there's a mistake here. Proceed until you get the last step. So Q here equivalent to 266 divided by 7. So it's equivalent to 38. So equilibrium quantity here is 38. But what about the equilibrium price? So equilibrium price here, we can use this one. Or you can also use this one, okay, to find the price, because now at this B point, this demand equals to P prime. Don't use the old supply curve here, because the old supply curve is not reflecting the text here. So now if I use the new supply curve, let me erase this mess first. Okay, so here we have 2Q, 2 times 38 plus 4. So you're going to get 260. So the new one here, 260, and 38 here. Alright, so I hope this is clear. So this is the end of linear functions. Alright, so thank you very much.